Welcome to episode 248 of CppCast, the first podcast for C++ developers by C++ developers. I'm your host, Rob Irving, joined by my co-host, Jason Turner. Jason, how's it going today?
I'm all right, Rob. How are you doing?
I'm doing okay. Don't really have much news to share, just another week under these current, somewhat stressful conditions. Yeah.
Yeah. I am definitely not teaching now at the conference in NDC Tech Town in Norway.
Okay.
Because that would have been remote and decided to not go with that. And, we'll see what happens.
Yeah.
My class in Stuttgart is still on as far as we know.
Okay. When is there like a date that you would have to make a decision on whether or not that might become canceled?
Or as far as I know, we're going to wait as long as possible and see how things are going in Germany, because that's the end of September. So that still gives us a pretty good window. That's another 4 months, right?
Yeah.
So there's still plenty of time to decide on that one.
Okay. Well, at the top of every episode, I like to read a piece of feedback. We got this comment on Reddit on last week's episode, which was about physical units. And this user, Phil, said, personally, I don't think adding physical units to the standard is a good idea. Maintain and use it as a third-party library, but don't force every compiler to ship it. For the same reason, we shouldn't add things like a currency class to the standard. I don't know about you, Jason, but I'm biased. I like the idea of having physical units in the standard because I would probably make use of it. But what do you think? I certainly think it would be more useful than a currency class and less likely to change frequently.
Yeah, I agree. Physical units are fairly constant. It's probably, I think it's the arguments that were made last week that something that's in the standard is like 10 times more likely to get used than something that's not is important to consider. Yeah. And something like units is important for correctness. We have lots and lots of code that's not correct that tosses units around right now. So,
yeah, I don't remember if he mentioned it in last week's episode, but there were cases where we've used the wrong units in some library code before, and space missions like NASA missions went badly because of it.
Things don't go right. Yeah, it's bad,
very bad. Okay. Well, we'd love to hear your thoughts about the show. You can always reach out to us on Facebook, Twitter, or email us at feedback@cppcast.com. And don't forget to leave us a review on iTunes or subscribe on YouTube. Joining us today is Martin Hořeňovský. Martin is currently a researcher at Loxley, where he works on converting large master key systems to SAT. He has taught modern C++ at Czech Technical University in Prague and maintains Catch2, a popular C++ unit testing framework, in the little free time he has left. Martin, welcome to the show.
Hi, thank you for inviting me.
Yeah, I'm looking at your bio and I'm like master key systems to SAT, and I have absolutely no idea what that means, but I guess that's part of what we're going to talk about with you today.
Oh yeah, I'll explain both.
Okay,
sounds good. Well, Martin, we got a couple news articles to discuss. Feel free to comment on any of these, and we'll start talking more about your work on Catch2 and maybe some more about SAT stuff, okay?
Okay.
All right, so this first one we have is a mailing from the C++ ISO committee, and I looked through a couple of these. I want to know if either of you have anything you wanted to highlight. One thing I thought was good was a paper on secure networking in C++, because it would be great if we finally get networking soon, but it would be a shame if it was only HTTP. So it's nice that they're starting to look at adding secure networking as part of it. And then there's also a paper on evolving C++ remotely, which kind of just lays out how they're going about standards meetings right now.
Yeah.
I like some of the little ones, like the nice placeholder with no name by Corentin, because I write in other languages which use underscore as ignore this, so I would love to have it in C++ as well.
Yeah, another paper references that one. I don't remember which one it was. I looked at the other paper first. universal template parameters, perhaps. And it looks like they're suggesting double underscore as the placeholder.
Yeah,
that's what they...
It's the C++ solution, right? You can't use single underscore because people already use it and you don't want to change anything, so you use double underscore. Make it more ugly. Okay.
Might have to be careful, though. There's probably double underscore identifiers in people's code. We'll have to use triple underscore, and then it'll all be better.
That's UV. That's not our problem. That's UV.
I'm actually involved in one code base.
Double underscore is reserved, so...
One code base I'm involved in right now uses single underscore for placeholders, where reading the code, I actually think that just for the particular use cases that they have, just an empty set of braces to say default initialize this thing would actually be better in most of those cases, particularly since it's a hack of a thing that we have anyhow.
Yeah.
One caught my eye here, and this is a conversation I've had with Ben Dean at one point. Attributes on Lambda expressions, which is David Inbal and Ville involved in it. And it's interesting, if you look at the grammar for Lambda expressions, you're allowed to put attributes in one place. And that one place doesn't do what you think it would do. It doesn't apply to the return type or to the type of the Lambda. It's just like, why is this even here?
Yeah.
Multi-dimensional subscript operator.
Oh yeah, we deprecated it for C++20. So the proposal is for C++23 actually enable it. So you can have multiple arguments.
Are you familiar with that one, Rob, that they deprecated the use of the comma operator inside the subscript operator?
No, I don't think I am familiar with that one. Why was it taken out in 20?
Because it was always just a hack and never did what you intended it to do.
That's not true. There was actually like one use of it in, I think, tests of some Boost library.
Right.
But nobody used it anyway.
I actually just recorded an episode for C++ Weekly on that just to demonstrate what it was and why it's gone and what it opens the door to now. So that's fun.
Yeah.
It's a relatively small mailing, but it's still a fair bit of things to look at here.
Yeah, it's definitely good to see that they're able to still make progress on all of these with the meeting that was supposed to be next month canceled. Yeah. All right, Jason, what's this new one? You were going over some Rust with your cousin?
Yeah, I just thought that maybe our listeners would be interested in it because we got pretty good feedback from the episode with Jonathan. Mm-hmm. So he and I did a 3-hour live stream on my YouTube channel of just him teaching me Rust. We started from the beginning, set up all the tools, install Rust compiler and all that stuff. And it's interesting to me, I guess. It makes me a little sad in a way. There were... not very much response on the C++ Reddit for it. There was about 5 comments, but 4 of them were negative. And on the Rust Reddit where we posted it, we got much more positive responses. So it was like, why, I don't know. It just made me a little sad that the C++ Reddit wasn't nearly as welcoming as the Rust Reddit was for this, but...
I'm curious what kind of negative comments you got, but if you don't want to go into it, that's fine.
Yeah, I don't see any reason to go into specifics here. Anyone could go and find the C++ Reddit on it. They were just kind of rude, and the Rust ones were like, oh, it's great to see these things from a C++ perspective or whatever. Yeah. Oh, well.
It's no harm in exploring other languages, I don't think you're not going to leave us and go start Rustcast and Rust Weekly, right? Okay.
So, Martin, you said that your Skype just crashed. I saw that message, which means you probably missed part of my rant there about my YouTube video, but that's fine. I don't think you missed anything important. You left Audacity recording the whole time?
Yeah.
Okay, good.
Okay. Yeah, and I'll edit that little bit out. Okay, and then the last thing we have, which I think we've put in the show notes before, is this list of C++ events that have been postponed or delayed or canceled entirely due to the coronavirus. It's being updated as new announcements are made, so we just thought it would be worth putting in here again. It does also have a list of some of these user groups that have gone virtual. Do you know if there's any specific events here that we should mention, Jason, that we maybe haven't mentioned before? Looks like CppCon, Meeting C++ are still on in September and November as of now.
Yeah. As of now, and Code Dive.
And Code Dive.
What's happening with NDC TechTown? It's also September.
TechTown is moved to online according to their website, but that doesn't seem to be on this list, is it?
That's a shame. Yeah, we should.
Yeah, it's not. That's why I'm asking.
Yeah, TechTown has definitely moved online. Their website has updated that.
It's now a 4-day online event.
Yeah.
Okay.
So we'll keep everyone up to date on this if CppCon, Meeting C++, or Code Dive changes. Code Dive's a little bit smaller conference, but it's a fun one. I like going to Poland.
There's also Microsoft, I think we mentioned that they did their Pure Virtual C++ virtual conference a few weeks ago. And this week, they're actually also hosting the Microsoft Build conference completely virtually. So I don't think there's too much C++ content in there, but I'm sure it'll all be available on YouTube or some other streaming platform once it's all over. So that's another thing that some listeners might want to go watch.
Yeah. I think we might have lost Martin again.
Oh, I see him. But he looks frozen. You're right. Hey, Martin.
Did we lose you again?
Okay. I'm back.
Did it crash again?
Yes.
Well, that's unfortunate.
Any idea what might be
Skype.
causing it to crash?
No, but I actually used the other client for this attempt, so maybe it will work now.
Okay.
Yeah, if it crashes...
Usually I use the Windows App Store one, so...
I
tried the old one instead.
I only use the desktop client, which they still update, the desktop client, and I disabled the app version specifically. Yeah, I hate Skype. We need to move to a different platform at some point, Rob.
I know. It's just we have all the built-in Skype recording software and stuff that works pretty well, but
maybe Zoom would be better these days. I don't know. Everyone has Zoom installed. That's what I know. And if you don't, you can just use the web version.
Although Zoom has a limit of how long your call can be.
If you don't pay for it. I've got a paid account now. Yeah.
Oh, you do? Okay.
Yeah.
Anyway. Okay, so Martin, we've obviously had Phil Nash on a couple times and talked about Catch. When did you take over maintenance of Catch2?
If you mean takeover, as in I was the sole maintainer, it's 2 years ago, I think.
Okay.
And I started 3.5 years ago, give or take a little bit.
Okay. And how did that process come about? How did you kind of take the reins away from Phil?
Did you wrestle him for it? Was it battle to the death?
No. No. We had too many beers, and the one who got drunk first lost.
Okay.
No, actually, it started with a CppCast episode with Phil on, where he was talking about, I think, his plans for Catch2, by which I mean at the time the next major version. And then I complained in the comments that it said that Catch isn't really maintained anymore because I fixed a couple of bugs for my own use, and the merge requests just were there for like the last half year at the time. So Phil offered to give me the commit rights to help him with maintenance, and then after about a year he stopped being active in the maintenance anymore, so I took over.
So how's it been going?
Mostly fine. I actually did retrospective at the start of the year, and I think I average out something like an issue a day.
Wow.
So it's fun. Basically, back when I opened my own issue against Catch, the number was 800 something. Today it's 1900.
That's 1900 issues that have been, resolved?
Yeah, and merge requests and stuff, but mostly issues.
Okay.
So
not 1900 that are still open.
No, 200 are open.
Yeah, it's really difficult.
It's 300 before I started.
Wow.
Yeah, it's a lot.
So what's it like? Is this your first experience being a maintainer of a popular open source library?
Sorry?
No, go ahead.
It was pretty much like my first experience with anything of the sort.
Okay. So what's it like, you just mentioned there's several hundred open issues still, which I know from having my own open source tools that's difficult to keep the issues down. This learning process of interacting with your users and trying to decide whose pull requests to accept and that kind of thing. Like, I don't know, do you have wisdom that you've learned over the last couple of years regarding maintaining an open source project?
Yeah, you have to realize that it's your free time that you are investing into it, and you don't owe people to solve their issue right away. Especially when it's like, I have 2 years old version of Catch on this computer I can't upgrade, and my compiler is 10 years old, and there is a bug. Okay.
Yeah.
There is a bug.
You're like, sorry, but I can't help.
Yeah. It's like, yes, you have GCC 4.4 on some obscure platform I have never heard of. You are on your own. Help yourself.
So just out of curiosity, do you ever, does anyone ever offer to pay you to fix an issue or something like that?
No.
No? My company relies on this. We're using a 10-year-old compiler on an obscure platform. Can you help us? If you pay me €100. No. Okay, never mind.
Doesn't GitHub have some sort of built-in support your open source developers Patreon thing now?
There is, yeah.
Quite recent, I think this year. And actually it's 2 weeks since they opened it in Czech Republic.
Oh, okay.
So if it's country by country. So if you weren't in the countries that were supported, you couldn't receive money. You could pay money, but you couldn't receive money.
Oh,
interesting.
So we already mentioned that you took it over from Phil, but besides the fact that there's fewer open issues now and that you're closing issues, is your style any different from Phil's as far as running the project?
Yes. You said we can cut parts, right?
If you don't want to talk about it, that's fine.
No, it's more like my basic rule for dealing with issues and feature requests is that I don't promise people things that I don't expect to be able to fulfill soon, right?
Okay.
If someone says, okay, I want this feature, and it's a feature that I want as well, I will say, okay, that's something I would like to have, and unless I know that I will get to the feature soon, I will not say this is going to happen next version or anything. Which feel like to go, well, we will offer support for property testing when Catch didn't even have generators, right? So then after another year, the generators branch materialized. It was broken. Then I fixed it, and Catch has generators. But that's not property testing, right? It's just generating inputs, but you don't have the shrinking and verification. So
you try to manage the user's expectations. Yeah. That's important.
The reality is I don't have that much time for Catch, right? So I don't promise things that I don't expect to be able to do.
Okay.
Makes sense. I think a new version of Catch2 was released recently. What were some of the features added there?
Bunch of versions actually, but there was like the one version for the V2 branch, which is what people use right now, the single header one, and that had some technically interesting changes. Basically, now if you shuffle the tests, you say, okay, I want to run all the tests in random order, and then you have use the same seed, but say I only want these 5 tests. Then they will be in the same order. Right? They will be randomly shuffled, but they will have the same relative order as they had when you had all the tests.
Okay.
And it's actually useful because when you find that there is some dependency between your tests, then you can say, okay, I will cut off half of the tests, and what does it do? Oh, it still reproduces. So I know these tests do not matter. So you can actually cut down which test you have to run to find the dependency. And then there was the much bigger release, which is a preview of the next major version. And that changes a lot of things, but it's the biggest change is that it will no longer be a single header library. Right?
That
now
is a big change.
Yeah, now you will just include the parts that you want, and there is also a static library that you will compile for the implementation itself.
See, this is interesting. I'm assuming Phil originally chose single header library because that's easy to adopt. It's easy to convince people to install a single header library. What convinced you to make this change to not being a single header anymore?
Basically, it's about future of Catch, right? The problem with having single header is that you either do not add new features. You have to say, okay, these are the features that I support. There will be no more features. Or you have to have configuration macros for everything. So then you have 50 different configuration toggles to turn this off, to turn this on, to include matchers, include generators, include benchmarking, disable matchers, and so on and so on. Or you have to accept that your library will have 1 megabyte as the header, and it will take forever to compile. Right? And if you actually look at the latest version of Catch, in the single header version, it already has 600 kilobytes as a header.
Right.
So and even the part that everyone includes, the one without the implementations, that has 4,000 lines of code and includes a lot of stuff and lots of standard headers. So basically the question is, what do I want in the future for Catch? And my answer was that I want more features, and that does not work with single header.
Right.
I want Catch to provide you matchers that you actually can use, and the matchers that people want to use, and generators and so on. But I already found myself saying, okay, this is a matcher that is interesting. I can see that some people would use it, but merging it into Catch would mean that there is quite a lot of extra code and extra includes from the standard library. But if only 1% of people, which is probably optimistic, will use this matcher, everyone pays for it, right? Everyone pays the compilation price. But only 1%, which is really optimistic, I think, would use it. So I had to say, okay, I am not merging this because it doesn't work for Catch.
Okay.
Makes sense. So, as we already talked about, you were a user of Catch before you started contributing and now maintaining the project. Do you still use it? Is that, were you using it as part of hobby projects or part of your day job?
I use it for my day job.
Okay.
It's actually, I ported our code base, my code base at work, to the new version of Catch. I got something 5% compile time improvements with the preview that I released recently, and actually 10% improvement with the version that's in Git right now.
Wow.
Which is, nice.
Yeah.
Not it just changes everything, but it's nice.
So I just saw a tweet from you this morning, I believe, unless I'm getting tweets confused, where you said you had tried to use extern template to improve your build times.
Yes.
With no success.
Yes.
Was that the header version?
The new one.
Okay.
Let's call it split implementation version. And the problem is that it actually makes perfect sense when you figure out what's going on, but it's unintuitive. Basically, the problem is if you extern template some class, you don't save yourself much because when you compile code that uses the class, the compiler still has to look into the class and instantiate most of it, right? It has to know how big is the class, what overloads does it have if you call some function on it, or member function, and so on. So if you say, okay, I'm extending this template class, then if there isn't some really big function, you don't get anything. It's unlikely that you will actually get some advantage from this. So if you want to extend things, it's probably better to go with template functions, function templates, because you can call functions without seeing their body, right? You don't need to know what's on stack in this function to call it. So you can say, okay, extend this function template, and then just call it. And that will probably save some time. It's on my to-do list to do some investigations about that.
I think so.
Maybe if I can digress a bit. So the thing I was trying to extern was unique pointer of test registration class.
Okay.
Right, because I tried the Clang build analyzer, and with the new Clang ftime, is it trace or report? They are both, and one of them does.
I think it's ftime report.
Okay.
Yeah.
So I typed Clang build analyzer, and it told me, okay, so the template instantiation that takes the longest is stud unique pointer for some catch internal class, the one that registers your test cases. And then there is another template instantiation that takes just as long, and it's unique pointer implementation called, right? It's some internal detail, and there are actually two or three more levels to this. So I thought, okay, I'm going to extend template this. It did nothing, and if I look at the sum of all the unique pointer instantiation times, it takes 10% of the time I spent compiling my tests, just instantiating unique pointers.
Wow.
So if in the future you hear me going, okay, unique pointers are overrated, Catch no longer uses them, that's why.
I just actually saw a project from someone that was showing how you can make a lighter weight standards conformant unique pointer if you use, C++ 17 features or whatever. I don't know what they did different, but I was looking at it and yeah, that's actually an interesting question because the standard versions of unique pointer are more complicated than you would think they need to be given the basic semantics of unique pointer and given what we all know it can compile down to in an optimized build. So it would be interesting to throw in your own simple unique pointer and see what difference it makes.
I might. I don't have to support all the things unique pointer does, right? I don't care that much for covariance. I don't care for deleters. I just want to call delete. So I could probably get rid of most of it.
Right. Yeah, that's a good point. Yeah. Templated deleter. Yeah.
This also I would like to return to the units library a bit. My opinion is that it's really nice. I would like to use it, but my experience with Chrono is that if you have a lot of code that uses Chrono and you try doing debug build, it will be orders of magnitude slower than if you have release build, which is a real problem, right? I have seen tests go from 1 to 2 seconds to run to minutes. Because the difference between, actually optimize all this Chrono like type code down to something reasonable and just leave it in as it is. So like that's my long-term misgivings about these libraries.
It's interesting because there's been lots of articles recently about Vittorio wrote an article also recently about the performance overhead that we get from the abstractions that we use in C++ in debug builds when we just have O0 turned on. And it's an interesting point because in my Doom experiments that I've been doing recently, and I guess I don't think we have mentioned that on the show, the 13-hour Doom stream that I did, a debug build of Doom, O0, can still manage over 60 frames per second at 1080p. And when I compile with O3, I'm at closer to 200 frames per second. So what am I talking about? A little over 3 times performance difference. And it's just using C code. It's not using any of these abstraction layers that we are used to using in C++. It'd be interesting to see how much slower I make the debug build potentially as I roll more C++ features into it.
Yeah.
How do you feel about like relying on O1 or OG or something like that in debug builds, Martin?
I don't think there is a support for it in MSVC, so I don't feel anything about it.
Yeah, let's see. You would have to...
And I don't know whether Clang supports it either.
Clang supports OG, but last I looked, it was a synonym for O1. It's just to maintain command line. Yeah.
It doesn't really.
Right.
Another tweet I recently saw from you, Martin, which I was curious about.
Your Twitter is coming back to haunt you now.
Well, you commented on our episode with Billy O'Neill a few weeks ago, talking about how it was from our discussion about suppressing warnings from included headers, I believe. And you talked about some awful code that exists in Catch2 to work around that. And I was curious if you could expand on that.
Okay, so the first thing to know is how Catch works, right? How come that the Catch can decompose the expression, right? So you write require. Sadly, no. So you write require A equals B. Right, that's what the user sees. And then after a couple of rounds of macro expansion, what you get is Catch decomposer instantiate is less than the expression that you had originally.
Okay.
Right? And the idea is that we insert some Catch type that has overloaded all the comparison expressions on the left. And because it evaluates left to right, then we basically change the type of the expression.
Okay.
This is okay, but there are some limitations, of course. One is that this causes ODR use of whatever is in the expression, which actually does change like this. I regularly get issues about code not compiling because Catch requires ODR use of what it gets. But the more important thing is that when we do this, it kind of breaks literals, integer literals most of all. Right? If you have some C code or C++ code and you write if some a variable that's of type unsigned int equals 2, then you will not get warning because unsigned int and some integer literal that's positive, that's okay, that's fine. But if you write require the same variable a equals 2, then what the actual expression will be is that the left-hand side remains unsigned int, but the right-hand side, the literal becomes an int, and then when we actually do the comparison, the compiler would complain, right? Because suddenly they have different signs. Right. So we have to disable this warning, or it will be too much noise. So how do you get the warning back? Well, what we do right now is that we have some really terrible expression, which is something like all of the require macro is enclosed in a do-while loop, right? And the while condition is 0, 0, and end. No, sorry, it's 0, false, and static cast bool of double negation of the expression. And what this does is that actually this is unevaluated, right? It will not be evaluated because it's behind a short-circuiting logical end, which starts with a false. So obviously it will never actually happen. But MSVC will look into the expression and issue warnings.
Okay.
So that's MSVC. And old clanks, like Clank 3.8 and earlier, actually also did this. Modern clanks do not, and GCC doesn't either. So what happens for GCC and Clank, and there is this like big footnote that says not all versions of Clank, because a lot of compilers report themselves as Clank, is that we actually use built-in what is it called? Some built-ins that basically says, ask the compiler, is this a constant expression, yes or no? But we don't care, so we just cast the return to void. But the compiler will actually take a look at the expression and complain if it sees some warnings in the expression.
Okay.
And of course, then someone opens up an issue saying, and we have this IBM XL compiler which reports itself as Clank, but if you give it an expression inside this built-in, it will generate these destructors. It will generate calls to destructors. Nothing else. It won't construct the object, it will just destruct them. What do you think happens when you type with a destructor and this happens? So there's actually like another, okay, and if it's like IBM XL, then don't do this. Just don't avoid anything. No warnings for you.
Wow.
And this is not all, because if you do this, Clank Tidy complains. Because Clank Tidy goes, oh, this is some built-in that I think it's a variadic function, right? So it will tell you, but you are using variadic functions. Don't use variadic functions. Variadic functions are bad. So there is also a note to the Clank Tidy linter saying, no, I know what I'm doing. Don't warn about variadic expressions. Well, calls to variadic functions here. So that's fun.
Yeah.
Wow. Yeah, that's...
And there is also some like extra fun because Clank Tidy has aliases, so some like warnings are aliases of different warnings, right? So there are actually two warnings that do the same thing but have different names for the variadic functions. And if you silence one of them, it will not silence the other. So that I actually am suppressing both of the warnings there, and I opened an issue with Clank Tidy because this is not how it should behave.
No, yeah, I saw you tweet about that too. I totally agree. So yeah, suppressing one should absolutely suppress all the aliases as well. That's So how much of those that kind of thing that you just described will you be able to remove when you're able to make the split version of Catch?
None of it.
Oh,
no.
Okay.
Oh, really?
Yeah, there isn't anything I can do with this, right? All of this is just to handle like taking an expression and actually being able to like take the expression apart, right? There is nothing here that I can help by not having more or less headers or less code.
Right.
Like, all of this logic just has to remain the same.
That's unfortunate.
Yeah.
It's not even the most terrible part of our macros. We have worse.
It's an interesting point. I was having a conversation with a friend recently about, sometimes, like I aim for simple C++ code. That's my goal. Sometimes you need the complexity to make the API simple, and then you try to hide that complexity. So thank you for hiding the complexity of Catch so that I can use a nice, clean, simple API in my code.
Yeah.
So we mentioned in your bio that you're currently working on converting master key systems to SAT. Could we maybe go into that a little bit and tell us what SATs are?
Okay, I'll start with the master key systems.
Sure.
First, so it's like really simple. Like when you have an office building, then usually you want like different keys to have different access rights, right? So there is a key that opens all the doors, a key that opens everything on a specific floor. A key that opens like the main entrance, and then it opens the electrical cabinet, but doesn't let people onto the floors, and so on.
Okay.
So that's called the master key system. You have some like relation between the keys and locks, and they can open each other, or they can be blocked. Like the key can be blocked in the lock, so it can't open it. And what we do is that we take these like systems together with a bunch of other rules, like how many positions are there on a key, how many cutting depths are there on the key, any constraints on the manufacturing, like you can't cut like too deep and not as deep on the next position, because you are making weak cuts, right? So if you cut deep enough, you already cut off the material from the positions next to it.
So we're talking about physical keys. I just want to make sure that's clear,
yes.
Brass keys. Okay.
Yes. And like it has a bunch of rules, like the rules that we can't actually make the keys if these rules aren't like if these rules aren't there, then there are rules for security reasons and so on. And so we make software that takes all these rules and then gives back the cutting codes for the key, which is like, okay, so you cut this position this deep, and so on. And the implementation detail of it is that we actually like take the system, we convert it to large logical formula, and then we just throw it into a SAT solver. Or rather, we used to do that like a year and a half ago. Now it's lots smarter, but we still use like the basic idea of converting, describing all the rules and the keys and the logs and the relations into logical formula, and then just telling some SAT solver to go and solve it for us.
Okay. And this is kind of like similar to like scheduling all the students in a classroom or whatever kind of problem. It sounds like to me.
Kind of.
Okay.
It's like the same computational complexity.
Okay.
You use different techniques for both. So that's what I do.
Huh. So then what is this? So a SAT solver is a constraint solver.
No. Well, yes, but no.
Okay.
Right, because the reason why I'm making the distinction is that actually they are actually like constraint solvers, which use a richer language to describe the problems. Right? If you are working with a constraint solver, you can say, okay, and these 5 variables all have to have different values. If you are working on the level of SAT solver, you have to say, you just give it a large logical formula in CNF form. So it's like conjunction of many disjunctions.
Okay.
Right. So you end up with like 10 million variables, couple 100 million clauses, and just tell the SAT solver, okay, go solve it.
So did you use you're doing this in C++?
Yes.
Are you passing? I'm sorry, brain. I have to take a step back here. One of the projects that I'm involved in describes the problem in a DSL, which then generates C++ code, which they then compile and run so that they can get the best throughput possible. That's the theory. It's a project that's currently in the works, but and to just complicate things, the actual like solver that generates C++ code is an open source project that's written in Java. So it just makes the whole thing, right? But the question is, are you doing something like that, or is it like a library, or what?
Well, we actually used to write out, okay, maybe step back. There is a format that's used by SAT solvers that pretty much every SAT solver understands. It's called Dimex, and like the first prototype many years ago actually just wrote out Dimex to standard out, and a different like binary just read the Dimex, solved it, wrote back the solution, and so on. And nowadays we use it as a C++ library.
Okay.
Are there lots of different libraries available for writing SAT solvers, or are you writing a lot of this code by hand?
There's a bunch of them.
Okay.
Well, there is a bunch of like SAT solvers, and you just use their API bindings directly usually. And I think I mentioned 2 or 3 SAT solvers in my CppCon talk. Like, here are some options, go use one of them.
Okay. I'll have to make sure to put links to those in our show notes.
Yeah.
Jason, you want to ask about the random blog post?
Sure. Yeah. So you recently posted a blog post on the issues with standard random. So I'm curious what issues you found, if you could describe that for our listeners.
Yes. Okay, so disclaimer first, I didn't find them. I was just the latest person crazy enough to try and standardize some fixes. Right?
Okay.
Actually, like the first paper trying to fix them is like 2016 or something. And how I like to describe the problem is that stdrandom doesn't solve anyone's problem, right? There are people who are beginners. They just want some random integer and do something with it. They don't care about portability, quality of the integer. They just want an integer. And these people are not served by random because, like, have you seen the interface?
It does take a few lines of boilerplate to get a number out.
Yeah, few lines. Look, I just want an integer, right? I don't want to go and figure out whether I should like have std empty 19937, or maybe I want, I think looks around 24, 48. I don't know. Well, I mean, I do, but like if you are a beginner, this is a lot of complexity you don't want to deal with, and then you have to also like seed the random number engine and so on. So, like obviously, it's aimed at experts. If you look at the interface, but the problem is it doesn't support experts, right? You can't, like, if you need portable, like, if you want to generate the same numbers using the same seed on different platforms, you can't use stdrandom. And this is then not an obscure problem, right? If you've ever played something like Minecraft or Terraria or anything that does procedural generation from seed, you probably want this game to generate the same world from the same seed, whether it's running on Windows, Linux, or Mac, or, whatever.
So why doesn't, I'm going to interrupt you. If I'm using the Mersenne twister that you alluded to, whatever, MT13, whatever, and I seed it the same, and I use the same distribution, why would I not get the same results on each platform?
Because every platform implements the distribution differently. So you get different results, right? The standard intentionally, and I think this was the wrong decision, but intentionally doesn't specify how the distributions are implemented. So every standard library implementation uses different implementation for their distributions, which in turn means that you get different results. And of course, you don't want to use the Mersenne twister directly because then you have the bias issues that we all know about. And these are the reason why we have something like better than stdrand.
Okay.
So this is like the first problem. And but the design of the stdrandom is that you can like write your own distribution and just plug it on top of the existing random number engines, right? Cool. But then you find out that every other layer in the stdrandom is also flawed, so you can't use it either. It's like, okay, so you have stdrandom device. The idea is that this is some way to get some randomness. Like this is an abstraction over platform-specific randomness, right? Mm-hmm. Sounds good. So what does the standard say? Well, the standard says it should provide like random bytes, or it might not. Just implement it with some random number engine, which is like deterministic, whatever. You can do that. And then it provides this member function called entropy. And in theory, you could call entropy and just go, okay, it tells me it doesn't have any entropy. It can't be random, right? If there is no entropy, it must mean that the output is predetermined. Well, actually, there is a problem. If you use libc++, it will never not return 0. It's just hard-coded, okay, return 0. But okay, so where does it get its random bytes? Well, it can either read defrandom, defurandom, NaCl, secure random, rands, and basically it uses a bunch of backends, and all of them are secure. Right?
And they all have different entropy, yeah.
They all should have like full entropy. They are like platform-specific, strong random functions. Some bunch of them are even like cryptographically secure and do provide that guarantee. So they just return 0. So this approach doesn't work. And it's still better than what the libc to the C++ does, which actually has even more possible backends, right? It has 6 different backends from which it can actually read the random data. And it either returns 0 as a constant for most of the backends, or it will actually ask the kernel how much entropy does the kernel think it provides. This is the configuration which reads from def random or defurandom.
Okay.
There is, of course, this obvious problem, right? This is like asking, does this file exist before opening it?
Mm-hmm.
Yeah, right. You don't do that. You just open the file, and if it fails, you handle the error. Because if you ask first and then try to open the file, you have erase.
Right.
You can find out that this is nice, and the file existed, and it doesn't exist anymore. So you shouldn't ask, just open. And this is the same problem, right? Is there an entropy? There is. Cool, let's give it to me. Is it still there? I don't know. And also there is like this massive digression because I don't actually believe in depletable entropy the way the Linux kernel does. And it's my, I didn't make any like real studies, but most people that I talked with in security context says that you do not like lose the entropy. Once you initialize the kernel, it initializes its cryptographically secure random number generator that derives more random data from what it has. You can't deplete the entropy pool anymore. So, like, apart from the fact that the entropy can't work because it's not like API that can work because of races, it's also useless.
Okay.
And MSVC is like the one platform that actually implements it properly. They just always return 32, like the full possible entropy for 4 bytes, and they just call into like the kernel provided cryptographically secure random number generation.
So one option that's guaranteed to be secure and with
But you basically have to either like start hard coding some list of platforms which work for you. Like you can say, okay, so if I'm on Windows and my libstdc++ version is less than 7, then it uses Merge and Twister, or it might be more, in which case it should use rands. Or you have to write your own like random device, right? Because at some point this is less work than just going through the different implementations and saying, yes, this version works. No, this version doesn't. And then
so what's your solution?
Yeah.
For this, it's like deprecate entropy. I would just remove it, but you can't remove things from the standard, so deprecate it. And my preferred solution then would be to just say, okay, if you implement stdrandom device, it has to provide cryptographically secure random bytes. This will never pass. So the solution that can actually get into standards is to provide basically two queries. One of them is this really random, or is this like just some wrapper over some pseudo-random number generator like std twister, like libstdc++ does, well, did on Windows? And the second query is this actually a cryptographically secure random data generator? Because this is what people care about, right? The entropy doesn't do anything for them.
Right.
And then there is also a lot of issues with seeding the generators, but let's not go over that.
Okay.
Yeah, I think we might be running out of time to go over that.
Yeah, well, before we go, were you able to present this paper at the last ISO meeting? Did you get any good feedback?
I presented all 3 papers. The feedback was, for the random device, it was basically that I should write the version that I just said and present it again.
Okay.
I'm not sure which of the other 2 papers was which, but basically one paper didn't have consensus to have consensus. Right? There was like basically the result of voting was this. Right? What?
Oh, okay.
Sure. Yeah. Okay.
And the third one, I think it was like weakly positive feedback, but nothing really interesting. So I will have to rewrite them and try again.
Wow.
I will have to be more persuasive.
So this might sound silly, but I will say the last few times that I've personally gone to use stdrandom, I have not been able to, not for any of the reasons that you said, but because I needed constexpr. I mean, if I give it a static seed and I want to generate the same set of generatable data.
There is no reason for this to like not work, but someone has to write the paper.
Right. And so I just have a constexpr random implementation I just pull around.
Yeah, sure.
Okay. Well,
there's no reason not to do it. Like, you don't allocate memory, you just do some computations. So
no, I'm pretty sure that the current stdrandom, except for the random device, could be just slap constexpr on it, basically.
Yes. Yeah.
Okay. Well, Martin, it's been great having you on the show today. Anything else you wanted to go over or put in the show notes? We'll definitely find the papers that you're working on and some of your CppCon talks.
No, I think that's like all of it. Unless you want to hear me rant more about stdrandom. I have many more words about stdrandom.
Maybe in a future episode after you get more feedback from your papers on it.
Yeah, I think that's a good idea. Okay. Thanks, Martin.
Thanks for going on.
Thank you.